Hello, this is Ryan Baker from Chem 122 class, and I will be showing you how to do a percent mass question and answer. Alright, here's the question.
To find the mass percent of dolomite in a soil sample, a geochemist titrates 13.86 grams of soil with 33.56 milliliters of 0.2516 molar HCl. What is the mass percent of dolomite in the soil? And below is the equation.
So in order to solve this problem, first thing we have to do is find the molar mass of dolomite. Like something like this. CaGCO3. That, we're trying to find the molar mass of this equation right here, this formula. So we got to kind of break it down piece by piece to get the molar mass. Ca is equal to 40.078 grams. Magnesium is equal to 24.305 grams. Carbon, there's two of them, so that's 12.011 times 2, which equals 24.022 grams. And then there's 6 oxygens, and oxygen's molar mass is 15.999, and then you multiply by 6 and you get 95.994 grams. You add all 4 up, 1, 2, 3, and 4, and you get the molar mass of dolomite at 184.399 grams.
And this is all the elements in their breakdown, and then you add them all up, and that's how you get the molar mass of dolomite.
So after you find out the molar mass of dolomite, you gotta take what you know to set up a stoichiometric problem in order to find out the amount of dolomite in the sample of soil. So first thing we're going to do is convert to moles of HCl, then convert to grams of dolomite. And I'll set that up by starting with what we have already, which is, in the problem it says we have 33.56 milliliters, but we want to convert that to liters, so you multiply that by 1,000 and you get 0.03356 liters. And then now we have to multiply that by the molarity of HCl. And the molarity of HCl is given in the question as 0.2516 mHCl. So molarity's conversion factor is moles over liters. So we're going to multiply that by 0.2516 moles of HCl over 1 liter. Okay, so from there we want to use that in order to go from there to dolomite. Since we have HCl, so we go by the ratio of HCl and dolomite in the equation. You'll see there's 1 mole of dolomite, which is CaMgCO3 2 for every so there's 4 moles of HCl for every 1 mole of dolomite, so 4 mole HCl. Okay, then from there we have to convert from moles to grams with the conversion factor we got earlier, which was 184.399 grams, which is in 1 mole of dolomite. Okay? Gee, sorry for the handwriting. And this is also, so this is the amount of mass in 1 mole of dolomite. And then after we multiply that, kind of cancel out liters, cancel out HCl, cancel out moles, and we end up with grams of dolomite in the sample. That equals 0.389252 grams of dolomite in the soil.
As we recap the problem we just went over, I just wanted to talk about finding significant figures, especially for addition and subtraction, like we did in the previous step, finding out the molar mass. When it goes to addition and subtraction, you want to have the least amount of decimal places be the last part for the significant figure. So since the least amount of decimal places in the elements were 3 decimal places, our answer had to have 3 decimal places, and that's how we came up with 6 significant figures once it was all added up.
So the last thing you're going to do is convert the number you just got for dolomite into a mass percentage to see how much soil is in the sample. So we got 0.389252 grams of dolomite in the soil sample, and we want to see the mass percent of dolomite. And so to find the mass percent of anything, it's always the sum of the parts over the whole. So mass percent equals 0.389252 grams over what we were given in the beginning, which was 13.86 grams of the soil. And you find your answer, and then you multiply it by 100, and you're given 2.808% dolomite in the soil sample. All right.
And just a little recap on how to get mass percent. It's the sum of the parts over the whole. So we had 0.389252 grams over what we were given, 13.86 grams. Find that, multiply by 100, and get 2.802% dolomite. Thanks for watching. Appreciate it. Have a good one.